Welcome at the DS Radio Shop. So today's hot topic for our morning rag net is going to be about modulation. We had somebody ask about modulation, and they wanted to know why it's so important to calculate when people say you don't need numbers, but you do need numbers. So we're going to take and show you just briefly. I'm not going to get a whole lot of depth onto this because you can spend the whole day talking about this and really burn out your brain. So let me bite this off a little bit here. I wonder. Hello, John. How are you? Good morning. Let's see if we can get a better view here of the radios. Morning, Matt, James, Steve. How are you guys? Okay, so we'll just do a short video here on modulation really quickly. So let me hit the light switch. So what we're going to look for is a modulated signal using this Galaxy radio that we're waiting for Chris to come by and pick up. Supposed to be anyways. We'll see what happens. Okay, so we're going to inject the signal. There is your signal. See if I can. Light switch would work better. There we go. Okay, not so fuzzy. Okay, so what are we looking for? Well, we're looking for our frequency response. We're looking for our modulated volts per division. We're also looking for our peak to peak. But we're also looking for the, when we say frequency response, like your time domain as to per peak. So for example, right here's our peak to peak. So you can clearly see where our peaks are. You can go anywhere you want. I'm going to go this way, make it an even from your center. 3 divisions up, 1, 2, 3, and then 1, 2, 3. So 3 and 3 is going to be 6. It's going to be a total of 6 division. Okay, and then we're going to do our minimum modulated carrier right here, which is going to be a 0.1 and a 0.1. So where these lines end up are going to be right there. It's your first gradual. So it's 0.1 and 0.1. So 0.1, 0.1 is equals 0.2. And if you do the math, it's going to be peak to peak minus 0.2 divided by peak to peak plus 0.2. That will give me my percentage of modulated waveform. Okay, so what that means is we take our 6 division, subtract your 0.2 is 5.8, divided by 6.2 is going to give you, I'm going to do that right here, 5.8. There we go. It's going to give you 0.935. Take that times 100 is 93.5% modulated carrier. Okay. Now, what about our cycle per division? We want to see what is the travel time from peak to peak. Well, we can adjust that by going. Oh, let's see. We can do this here. Let's get that lined up right in the center. So we've got our 1, 2, 3, 4. So that's 4 cycles per division. Okay, so real simple to figure out. It doesn't take a lot to figure out, guys. So that's what you want to do when you're looking for a modulated waveform, is to calculate exactly what you have. So we know we're at our 6th division, but we also know that we're at our point 1. That line is right at point 1. So that's giving us a good clean sine wave. If anybody got any questions about that? It's a really short video. We're not going to do a big video into this because it doesn't take much to calculate and figure it out. So you don't have to overthink this. A lot of guys do. It's something new for people, and then you're probably going to overthink it. I believe everybody, probably does that. How I did too when I first started learning all about this way back in the day. So, but yeah, it's not hard to do. It's just a matter of getting your proper calculations, and you go from there. That's pretty much the only demo we're going to do as far as the modulated waveform goes, because it's pretty straightforward. It really is. So let me get this pushed back, get out of the way. I don't think it's going to be too early, but we're going to see if anyone is on. And of course, nobody's on. It's too early in the morning, so we're not really going to skip conditions right away, but that's okay. It's all right. Anybody got any questions on modulation waveform or cycle per division? And I say it's really easy to do. We can write this down quickly for you. So you're going to take what they call AB over AB equals decimal. So there's 100 equals percent. See if this helps anybody. There's your formula, guys. Really easy to figure out, like I say. It's not hard to figure out at all. Get that glare out of the way. Morning, bootlegger. How are you? Above your pay grade? What do you mean? So if anybody wants to break this formula down, feel free to do so. Take a screenshot of it later or something, whatever you want to do. But that would be your simple basic formula. You're going to take your peak minus your minimum voltage modulated carrier, as people call valleys. Okay? So A minus B divided by A plus B. In this case we had 6th division minus our minimum voltage modulated carrier 0.2 equals 5.8, and then 6 plus 0.2, straightforward, 6.2, right? Take the 2, divide it, you're going to get a decimal, 0.935, there's your decimal, times 100 equals 93.5% modulated waveform. Now, the other part of that question is people say, how come it's not 100%? This radio is running at 100% of its capability. So that is a true statement as to, is this radio perform 100%? Yes, it is, at its capability. Okay? It doesn't mean you got to see 100 on every single radio. Okay? You put the waveform where it's the best, cleanest waveform between your scope and your spectrum analyzer, and you get the percentage of calculation all figured out, and that's where it's going to be. I've seen some at 98, I've seen some at 100, I've seen some at 96, 97, 95. When they all come out of the factory, typically, they all begin between 90 and 91% anyways. So anything above that, if you look at the procedure book, it says shoot for 90% to 100% modulated waveform, and that's what we do. So we look for the best waveform we can get, the cleanest waveform we can get, and keep our harmonics very low to minimum to the noise floor, so we have nothing to splatter whatsoever. It has to be close to a perfect world, we'll say, of no interference, right? No splattering. So therefore, this will be your formula to figure that out. Now, if some of them may end up 94, 95, 96%, okay, cool, even better. That difference of percentage is not going to change in the real world what your signal going out of your antenna is. It all comes down to a good antenna, a good SWR, good ground system, and a good clean sounding radio. And the rest is going to be up to conditions and different atmospheric ratios, etc., and absorption, etc., etc. So yeah, it's not really hard to figure out, guys. It truly is not hard to figure out. So not at all. So there you guys have it. Just wanted to talk about this morning. Seems like I got multiple emails question about modulation again because they're learning, which is cool. There's no wrong question whatsoever. They were asking because they want to know more about it, because they're getting into learning how to troubleshoot, how to analyze, etc. So I think that's a good thing, and it shows people's interest into the hobby, which is wonderful, for sure. So yeah. And of course, nobody's on so early in the morning. 20 after 7. Anybody got any questions on excuse me, modulation waveform or calculation percentage rate? Anybody got any questions about that? It's pretty straightforward, it really is. Morning, Bhaskar. How are you? On a different note, it's going to be 45 degrees today, light rain. I will take that all day long as I'm tired of the snow. So I'm okay with the rain. Get all this stuff melted down, which is working out pretty nicely. Yesterday it wasn't so bad. I think I hit 43 or something yesterday, so that was pretty good. For sure. So, anyways, anybody got any questions? You guys were pretty much a quiet group this morning. M. Williams says, great explanation. Good morning to you, sir. Hope everything is warm and the apple tree. Yeah, so far it's warming up. Going to be 45 today, so I'm looking forward to that. Morning, Brian. How are you? How to sound like the ham operators. Well, there's two things you got to realize. Okay, one, get a good ham radio because they have really good low pass, high pass filters involved. They've got good filtration, roofing filters, well designed audio circuits, etc. And so, right there in its own will be a huge improvement over a CB radio. However, because of the quality of the build, a lot of guys cheat, and I don't like what they do. This is just my opinion. You have a radio, and it's supposed to work the way it's engineered and designed, right? So long as you have it work exactly as such, it's going to work fine. You're going to sound great. Now, a lot of guys, what they do is they'll take a equalizer system, a mixer, and they got this, like, we'll say like the size of this here radio. You'll see this huge machine right here that's got the equalizer and it's got a mixer system and all that stuff, and they make it sound like an FM broadcast system. So wherever you go, they sound really like loud, clear, and unbelievable, right? That's what they are using. I don't believe in using those because I feel that if I have to improve my station that much, then that means there's something wrong with the build. Something's not right. Because, in other words, you're not going to want to buy I'm going to put this here in an easy way. The best I can put this, right? So, you're not going to go out and buy a brand new car today, and then you're going to change half the motor around, or add a different muffler system, we'll say, because you want that car to sound a little bit different. So, however it's built, that's how it's built, that's the way it should be ran. There are room for improvement, which is okay, nothing wrong with that. I just don't believe in putting mixers or stereo equalizers and all that to my system, because if I have to do all of this to make that radio work, especially for the ham radios, my God, you and I and everybody else knows ham radios are not cheap like CB radios, right? So your ham radios are, we're into thousands of dollars, right? So like an ICOM 7300 is, $1,100 brand new. Yaesu 9918, $1,300 brand new. Yaesu 9000, they're almost like 18, 20 grand, and they go right on up. So, I mean, would you spend that kind of money on a radio that you would expect to perform 100% at its ability right now, the day you buy it? I would expect that out of the radio. If I have to buy an equalizer system and a mixer to alter my voice to make that sound good, after spending all this money on equipment, then I wouldn't even want the equipment. I would get right out of the hobby at that point, because now it's becoming more of a money pit. And now that becomes, in my mind, the way I look at it, is more of a political aspect of things, because politicians go after one thing, your money, right? So if you have to enhance your system and keep spending money, then that kind of puts you in those categories, we'll say, with all due respect, right? So I don't believe in mixers, I don't believe in equalizers, I don't use any of that stuff. I use whatever the radio will do. And also based on your voice, if your voice is deep, some guys are really deep, some guys have a little bit more of a treble voice versus more of a bass. So it kind of goes with that too. And then the style of the microphone. Now if you want to improve your radio, a good quality desk mic, that I can see doing, yes. Outside of it, I wouldn't change where I have to put a mixer or an equalizer in there to make me sound, like a FM broadcast system, professional radio operator. Because if that's what I got to do, then There's no professionalism behind it. That's the way I see it. I'm more of an old school, run of the mill type guy that whatever I have, I just keep it simple and let it run. Morning, James. How are you? And Williams says mid-50s today. Cool. Bootlegger says, I am just simple CV man. There you go. Keep it easy, keep it simple for sure. Good question though, Boxcar. It is a good question, yes. There's nothing wrong with adding more stuff. I just don't feel the need to do it because it just, to me, it's money. Why put money in having more equipment to sit here? I mean, I'll give you an example. I have a, we'll say like right here, let me get this out of the way. Hold on a second. I got all kinds of stuff in my way here. Alright. Let's say we have like these radios here. A Yaesu 991A. Well, those are $1,300 radios. Okay? Then you got yourself a Yaesu 920. Another nice radio. Very classic radio. Then you got an ICOM 7300 right below it. Of course, you got a Yaesu 840. Just, basic radio, but it works really well. Then we go over here, you've got yourself a lot more selections, right? All these radios. Got the Yaesu 5000 down here at the bottom. Got a Yaesu 1200 right here. Got a Kenwood 940 right there. I mean, I don't see the need of putting all this extra money into something that, if the radios work the way I want them to work, I'm happy. I thought about getting the FM broadcast, equalizers and stuff, but nah, it's just not for me. I don't care for all that stuff. I mean, would it improve audio sound? Oh yeah. But a lot of these radio shops are doing that, so when you hear it over the air, then they say, oh yeah, here, how's this sound? Yeah, man, you sound awesome. But when you get your radio back, you hook it up, how come I didn't sound the way you sounded? Because they have all this stuff. People they're not gonna want to put a mixer and equalizer inside your car and have it all souped up, or you got half the car loaded down with equipment just to sound good. I wouldn't do that. Hey Steve, how are you? Good to see you on. I figure if I can, I don't know. I've seen some stations that are just mind-blowing. They've got all this money tied into it. They sound great. They sound awesome. I'm just not there to be wasting my money on an equalizer or mixer, but that's how they do the whole thing when you want to, when you ask about how do you make it sound like a ham radio. Well, either they're using a ham radio or they are using some kind of a mixer system equalizer to enhance that audio. Would be what I usually see most of the time. So that's how they also get false information on your oscilloscopes and spectrum analyzer for the ones that the very few who actually use those. They use that a lot of times. And when you get your radio back, you take it to another shop because someone says you sound distorted. You put it on a spectrum analyzer without all those additives of equalizers and mixers and etc. Then you find out, wow, this ain't splattered like really bad. But they make this sound so clear and they clean it all up with all these controls to make you sound really good when they get inside and they crank the living hell out of your radio. And I've seen guys do that before too as well, which is crazy. So, but hello Radio Man, how are you? What's an ideal antenna height? 25 minimum, 30 feet. Yep, that'd be about right. Yeah. Go with a Stereo GPE 27 on Amazon. It's a 5/8 wave. Aluminum ground plate antenna. Do not buy an Antron. You're going to waste your money. Or else you can go with a Colossal. 10K, those are nice. If you also want to go with a, if you want something like really simple and you want to put it up around 40, 50 feet, get a Predator 10K. But they're nice for sure, yeah. Condenser or versus dynamic, which is better for AM sideband? Well, that's kind of your preference, really. It depends on, I guess, the radio that you're using, in a sense, because I've seen, Steve says, sweet, I found a tower. Oh, cool, awesome. There you go. Yeah, you know what you could, oh, you got a Star Duster? Oh, they're really nice. You know what you could do, Steve, is get yourself a crossbar. So you got a mast coming out of that tower. We'll say 10 feet above your tower. I'm assuming it's 30 feet tower. So let's say you got a 10-foot mast coming out the top of the tower with a ground plane antenna. Then do a crossbar that comes out 5 feet down from the top of the antenna. Have a bar coming out about, I don't know, maybe 5-6 feet away from it. Clamp that down nice and tight and put yourself a Predator 10K mobile antenna. And then what you can do is compare the two and see how well you do. Because the Predator 10K has got about 10-12 dBi gain, whereas the ground plane has about 6. Some of them have 3.15. So, but anyway, so back to the other a Delco mic you use from the 80s on your 2980, and then you were told you sounded like a broadcast. Cool. There you go. Yeah, it kind of depends on what you're going to use it for, what application you're going to use it for, because it all comes down to the impedance of what you're using to match for the mic element, whether it be condenser or it be dynamic. So it kind of depends on the radio. It depends on the applications you're using it for, which would sound better quality. So really can't answer that because it's kind of up to you as to what you're using and kind of go from there. Really, I mean, both are great, but it depends on the radio and the setup that you're going to use will determine which one is going to overrule the other. So yeah. All right, guys, I'm going to get on off here and get a few things started. So we'll catch you guys all here a little bit. The DX Radio Shop. Good questions. Appreciate that for sure. And we'll see you soon. Like, share, subscribe. Hit that bell. And you'll always get your alerts. If you have any troubles with it, unsubscribe and resubscribe. Sometimes YouTube has some glitches in between, but you are always going to catch me on here just about every day, all day long. So catch you guys later here on the DX Radio Shop. Thank you all.